All right, here we are back. We want to talk about temperature conversions. For this video, you're going to need to grab your calculator and, of course, a paper and pencil. Now, before we start, we'll talk about rounding and significant figures later, but you'll want to write the answer to the same number of decimal places, no matter what units you're converting from and to, okay? Now, when you're doing the temperature conversions, there's nothing fancy you need to do. You just need to follow the formula that's given to you that will be provided to you on an exam or something in my class, okay? So, example, what is the degrees Fahrenheit of a Radeon graphics card operating at 51 degrees Celsius? So, essentially, it's just plug and chug, but remember about the rules of operation, please, when you do this, okay? So, what we want to do is set this up. So, F is equal to 9/5 times the Celsius temperature, which is 51. And then we want to add 32. So from rules of operation, you do this first. Okay, so on my calculator, I'm going to do 9 divided by 5 and then hit the equal key. And then I'm going to multiply by 51. Okay, and I get 91.8. And then I add 32 to that, and I get 123.8. Now here's the issue, okay? This is not a math class where we're solving an equation for F. In chemistry, we always put the units after a number. So we want to write 123.8 degrees F with that little degree symbol. But first of all, like I said, for the rounding, you want to round it to the same number of decimal places. 51 is just to the ones place, so you want to round this to the ones place. So that's going to be 124. And then we want to write degrees Fahrenheit. And I always like to box my answer so I know what the grader is going to be grading, okay? Let's do another one. What is the degrees Celsius if the temperature is 98.6? So this is accurate out to the tenths place, so we want whatever answer we get on our calculator to be the tenths place. Remember the rules of operation. You do this part first, okay? And then you divide by 1.8 after that, okay? So let's go ahead and plug that in. We have F minus 32, which is going to be 98.6 minus 32, and we're going to divide that by 1.8, okay? And I even put parentheses in there so you would know what to do first. So grab your calculator and type 98.6, subtract 32, and hit the equal key, all right, or the answer key, and I get 66.6, all right? Now divide that by 1.8 on your calculator and hit the equal or answer key, and you get 37 degrees Celsius. Okay, we'll just leave it like this. Really, I should put 37.0 degrees Celsius, but I'm just going to write 37. Okay, so that's body temperature. Here's a problem. What is the Kelvin temperature of an object at 4,500 degrees Celsius? So basically, you just take this 4,500 and you add 273.15 to that. So let's do that just on our calculator here. 4,500 plus 273.15. Hit the equal key. I get 4,773.15. But again, we're going to round this off to the ones place. So that's 4,773 Kelvin. Okay, and just down here, I'm just going to make sure I show you what I do not want to see. Don't write it like a mathematical equation. Write the units after the number, okay? So I hope this video helped you. That's basically what we've got going on here. I do have a practice problem for you before I leave. What is the effective Fahrenheit temperature of a light bulb rated at 3,700 Kelvin? So 3,700 Kelvin, pretty hot, and it's going to be a certain brightness, like a dim yellow maybe, and you want to calculate what is the Fahrenheit. So here's your practice problem for you for this lecture.